Trigonometric expressions, cofunction identities, Thursday, November 24th. Let's move on. Today you will learn certain trig expressions that are equivalent, and then you'll use them to solve problems. Let's begin with a short investigation. It says sketch triangle ABC such that angle B is a right angle. Mark angle B as pi by 2. Mark angle A as x. And then decide what C is based on the other two terms. So this angle here, C, is going to be equal to pi by 2 minus x. Determine an expression for sine x in terms of the sides triangle ABC. So I'm going to label the triangle. Across from big A is little a, across from big B is little b, and across from big C is little c. So then if I want to try and find sine of angle x, which is where the A is equal to the opposite, which is A, little a, over the hypotenuse, which is B. Now I need to find expressions for sine, cosine, and tangent of angle C, so this angle here, and then to see if any of them are equal to sine x, which is A over B. So looking at angle C, I could say sine, let's use C for now, is equal to, across from angle C is little c over the hypotenuse B. Cos of C equals adjacent, so A over the hypotenuse B, and then tan of C is equal to opposite, which is C over little a. You'll notice that cos C is equal to sine x, but we know that cos C is really the angle pi by 2 minus x. So we can state then that sine x is equal to cos C, but C is really pi by 2 minus x. If we were to continue this investigation, we would come up with the other equivalent expressions that will be shown on the next page. An identity is an equation that is true for all values of the variable for which the expression on both sides of the equation are defined. Those that we're looking at today are called cofunction identities. Here are the numerous cofunction identities and other identities that we can use today. Notice that sine x is equal to cos pi by 2 minus x. Similarly, cos x is equal to the sine of pi by 2 minus x. And that continues for the other ratios, even though we generally focus on the sine and cosine. Other identities based on the unit circle, we can find that sine of x plus pi over 2 is equal to cos x, and the cos of x plus pi over 2 is actually equal to negative sine x, so here we got some negatives. Tan of x plus pi over 2 equals negative cotan x, and then cotan x of pi over 2 equals negative tan of x. And I'll stop there. Okay, so trying out these cofunction identities up here and other identities, I'm going to go do A through F. So looking at A, we have sine of pi by 2 minus pi by 5. So sine of pi by 2, right here, minus some x value, say pi by 5, is actually the cos of that same value. So sine of pi by 2 minus pi by 5 is equal to cos of the pi by 5. Similarly, in the next question, sine of pi by 2 minus 2 pi by 7 is equal to cos of 2 pi by 7. The last one is a little bit different. It's actually using the adding properties. So sine of some pi by 2 plus some angle, so sine of pi by 2 plus some angle, we'll see that right here, pi by 2 plus some angle is equal to the cos of that angle. So in this one then, I would say that sine of pi by 2 plus pi by 8 would be equal to the cos of pi by 8. Doing the other half of the screen, I can see that cos of pi by 2 minus some angle x. So let's look up here. Cos minus an angle x is actually equal to the sine x of that angle. So if this is the x here, then we want the sine x. So that would be sine of pi by 3. Again, similarly, we get the sine of 2 pi by 5 for the next question. And lastly, we're looking at the adding property again. So looking at pi by 2 plus some angle. So cos of pi by 2 plus an angle, looks like it's here, is negative sine x. So if this is our x value here, then this answer would be negative sine of 3 pi by 8. Thank you. Okay, so in this question we are given tan of pi by 3 equals root 3. And we've been asked to show that cotan of pi by 6 is equal to root 3 also. So I'm looking at this and I can see that pi by 6 is actually smaller than pi by 3. So I'm working with these subtraction cofunction identities here. So the cotan of something, pi by 2 minus x equals the tan of x. So I'm hoping that that will work. So let's check that out. So pi by 6 is equal to pi by 2 minus some value. And I'm using the pi by 2 minus a because of the subtraction identities up here. So they're all pi by 2 minus x. So I'm going to solve this problem. So rearranging, I get that a equals pi by 2 minus pi by 6. Finding a common denominator, I get that 3 pi by 6 minus pi by 6, which equals 2 pi by 6, which equals pi by 3. I can rewrite this expression here, cotan of pi by 6, as the cotan of pi by 2 minus this pi by 3, because that's what a is. And from the expressions up here, I can see that the cotan of pi by 2 minus x is actually equal to the tan of x. So is actually equal to the tan of whatever x is. And this here is my x, so pi by 3. And we know from up here that tan of pi by 3 is equal to root 3. Therefore, the cotan of pi by 6 equals root 3. Given cosine of 2 pi by 9 equals 0.766, I want to prove that sine of 13 pi by 18 equals 0.766. Because 13 pi by 18 is actually bigger than pi by 2, I'm going to be looking at the other identities where we're adding the pi by 2. So I need to write 13 pi by 18 as x plus pi by 2. So I'm going to use a as my variable, but 13 pi by 18 is equal to a plus pi by 2. I'm going to solve this equation. Rearranging, I get a equals 13 pi by 18 minus pi by 2. Finding a common denominator, I get 13 pi by 18 minus 9 pi by 18. Reducing 4 pi by 18, I get 2 pi by 9. I can rewrite our sine expression as sine of 13 pi by 18 equals sine of pi by 2 plus 2 pi by 9. And from our expressions up here, I can see that sine of x plus pi by 2 is equal to cos x. So here's the pi by 2, here's the x. So this must be equal to cos of, not the pi by 2, but of the x. So cos of 2 pi by 9. And if that's true, then I can go back to our original statement where cos of 2 pi by 9 is 0.766. And I have proved that sine of 13 pi by 8 equals 0.766. Thank you, and good luck with your questions this morning.